Students, in this class we will learn how to evaluate integral 0 to 1 log x raised to the power 2021 times dx. Now before we could do this question, let us understand how to do this question. Integral 0 to 1 log x dx. Now clearly this is going to come under the category of Liate. So what I'm going to do is I would be using my u to be as log x and my dv to be as dx. Now differentiation of u would give me 1 over x times dx, and differentiation, or I would say the integration of dv, would give me x. So the formula integral u dv is equal to uv negative integral v du can be rewritten as, in the place of u is going to be log x, in the place of v it's going to be x. So the limits are 0 to 1. Negative integral, in the place of v is going to be x, in the place of du is going to be dx divided by x. So my x and x can be cancelled. I substitute log 1 is going to be log 1 and 1, negative x is going to be 0 times log 0. So clearly this is going to get cancelled, right? So you can cancel this off, and followed by negative integral of dx. Now this is going to give me negative of x within the limits 0 to 1, which would mean I would have negative of 1 negative 0, which is equal to negative 1. This is what I get for the first term. If I have log x raised to the power 1, that is very important, you have to note that. Now let us see what happens when we integrate 0 to 1 log x raised to the power 2 times dx. So what happens if I were to take u to be as log x raised to the power 2 and dv to be as dx? Now this is going to give me du equal to 2 times log of x raised to the power 2 negative 1 times differentiation of log x is going to be 1 over x times dx. Now in this case I would have the integration of dv, that would give me v, integration of dx would give me x. So substituting it in uv negative integral v du, we would get u is log x raised to the power 2 times v is x, the limits are 0 to 1, negative integral v is x, and du is going to be 2 times of log x. 2 negative 1 is going to be 1, so it doesn't matter there, multiplied with dx over x. So the x and x gets cancelled. This is going to be 0 clearly, so you cancel that out. So this is going to be equal to negative 2 times integral log x times dx. Now this can be rewritten using the above result that we have got. When we integrated this, we had this to be equal to negative 1, right? The result for the integration of this landed as with negative 1, so that's going to be equal to positive 2. So the most important aspect that you have to know is when I add integral 0 to 1 log x raised to the power 2 times dx, I get an outcome as negative 2 times negative 1. So just for the sake of consistency, let us now consider integral 0 to 1 log x raised to the power 3 times dx. What happens? Now my u is going to be log x raised to the power of 3 and my dv is going to be my dx. So you differentiate this, you get du is equal to 3 times log x raised to the power 2 times differentiation of log x is going to be 1 over x times dx. In the case of integrating dv is going to be v is equal to integral of dx is going to give me x. So this is what I get. So using the formula uv negative integral v du, I would now have in the place of u it's going to be log x raised to the power 3. In the place of v is going to be x. The limits are 0 to 1, followed by negative integral v du x times. My du is going to be 3 times and followed by log x raised to the power 2 times dx over x. So my x's can be cancelled here. Okay, so this is going to be 0. So the outcome is going to be negative 3 times integral 0 to 1, the limits, log x raised to the power 2 times dx. But this result, when we integrated integral 0 to 1 log x raised to the power 2 times dx, we got negative 2 times negative 1. So this is going to be negative 3 times negative 2 times negative 1. This is what we get. So I can rewrite, therefore, integral 0 to 1 log x raised to the power 3 times dx to be as negative 3 times negative 2 times negative 1. And also when we worked out integral 0 to 1 log x raised to the power 2 times dx, we got negative 2 times negative 1. So you can clearly see the pattern here, right? So therefore we can conclude, if I were to integrate 0 to 1 log x raised to the power 2021 times dx. Now this is actually an odd number, right? Now when the degree was even, integral 0 to 1, the degree is an even number, we had a positive sign. But when the degree was an odd number, we had a negative sign. So this is going to be actually negative 3 times 2 is going to be 6. So I can in fact rewrite this as negative 3 factorial. Okay, now you can try out for any number and you will find out that depending upon the degree, say for example, if I would have something like this, let me show it to you here. Say integral 0 to 1 of log x raised to the power 5 times dx, then the outcome is going to be negative 5 times negative 4 times negative 3 times negative 2 times negative 1, which is clearly you will have a negative sign, and this is nothing but 5 factorial. Okay, now if it was, say, integral 0 to 1 of log x raised to the power 6 times dx, then the solution is going to be positive 6 factorial. So the even number will give you a positive sign, the odd number will give you a negative sign. So using the above information, I can clearly conclude the outcome for this is going to be negative 2021 factorial with a negative sign. So this is going to be my solution for the given question.